Beamforming focuses RF signals towards a multitude of clients with the goal of providing consistent capacity. Beamforming can be done either in silicon or with software steerable dynamic antennas. When beamforming is done in silicon, it requires cooperation from the clients, and hence it requires 802.11n standard support. Currently, that is an advanced option in the 802.11n standard, so it's currently not available, but people are working on it, and it may or may not become available in the near future. Now, the software steerable dynamic antennas work with or without this 802.11n client support, and they will be additive to it when it becomes available. The dynamic antennas use standard medium access mechanisms and don't require this client support. When we talk about beamforming, we generally talk about transmit beamforming because in receive beamforming, you know what you're hearing, and you can do what is called maximal ratio combining. So you can combine the signals from the multiple receive radios in an optimal manner. And this is available to all 802.11n chips and systems. So basically, transmit beamforming is for transmit once again, and MRC is the analog to a receive analog to the transmit beamforming. Well, by being able to focus RF energy in the directions towards the client, the beamforming can control the signal reflections which are available in the environment with the goal of providing consistent performance to a particular client or to a set of clients. And this is necessary for applications such as latency-sensitive video streaming. By being able to keep the packet loss to a minimum in the presence of interference and various other multipath fades, once again, the throughput to the application is kept steady, and that's very, very, very important. Also, beamforming improves system-wide capacity, and it improves system-wide transmission reliability by reducing the radio fog. One way to look at beamforming is as an over-the-air router, which consistently adapts to the changing environment. So once a better path becomes available, beamforming will find that path and will provide that path to the client. Ruckus has revolutionized the area of smart antennas and dynamically steerable antennas, software steerable antennas. It is the only wireless LAN company to successfully implement dynamic beamforming using a dynamic antenna. And here's an example of one of our antenna structures. This structure is capable of generating high-gain directional patterns in both azimuth and elevation. And this is important in case the access point is mounted on the wall or the access point is mounted on the ceiling. This antenna structure is specifically designed to be dual band, meaning it works with 802.11a, which is in 5 gigahertz, and it also works with 802.11bg and n, which is in both 2.4 and 5 gigahertz. The antenna is capable of mitigating interference and avoiding interference, and this is all done automatically via the smart software.